I am the Android developer at a small company called Pixite. We make creative consumer apps and that sort of thing. Today I'm going to talk a bit about testing in-app billing. So our primary app at Pixite, its primary revenue source is subscriptions, in-app subscriptions. So I spent a lot of time dealing with in-app billing and subscriptions and that sort of things. And one of the things that I found is that it's really hard to test, all right? So over the last couple years as I've been working on this app, I went through a few different iterations of ways to make this easier, and I want to share the latest iteration of that with you today. First of all, though, I want to talk about in-app billing in general. So this is just sort of a high-level overview. Think of this as in-app billing the hard way. So way back in the beginning, there was AIDL. So if you wanted to do in-app billing on Android, you use the Android interface definition language. And basically what this was sort of a Java interface class that you would copy into your code. You would copy and paste this in-app-billing-service.aidl file into your code. And then you would use that to connect to the Play Store via service connection. So this is sort of Android 1.0 mechanisms here. You would have to manually manage that service connection. So anytime an activity is paused or resumed or anything like that, you have to deal with the service connection, make sure that it's handled accordingly. And you also have to make sure that that service connection stays connected because you might get disconnected for different reasons within the system. And you would use that AIDL file to communicate directly with the in-app billing service. So this is sort of the origins of in-app billing on Android. And this is what it would look like. So library code would be the Google Play app. I believe at the time it was called Android Market. And there's a service built into that app that you would connect to using this in-app billing service. You would manage that service connection yourself, and then you would talk through all of that with your existing code. Now all of that was code that you had to manage. All right, so this was sort of a lot of overhead to interact with these services. So there were a lot of third-party libraries that cropped up to make that a little bit easier for you. They would kind of wrap that code that you were supposed to manage and provide different ways of interacting with this service. Because these were all third-party solutions, there never really developed a single solution that sort of became the canonical solution, sort of like retrofit is to API access. So, because of that, a couple years ago, Google released something called the Play Billing Library. And the Play Billing Library is part of the support library, Jetpack, Android X nowadays. And basically what the Play Billing Library does is it wraps that AIDL service binding. So it manages all of that for you, just like those third-party libraries did, so that you don't have to. It's based on an abstract billing client class. So the primary class that you interact with to use the Play Billing Library is this single abstract class. And that's important, and we'll come back to that later. And as of Google I/O 2018, the Play Billing Library is the official supported solution for interacting with Play services. The AIDL solution is still there, and it's still supported, but Google's kind of said that's a low-level interface that you really shouldn't worry about. They recommend that you use the Play Billing Library. So we saw before that the AIDL, sort of looks like this, where you have a whole lot of code that you need to manage. And what the Play Billing Library does is it moves that code up into that library code that you don't need to worry about. Which is great, because anytime you reduce the amount of code that you have to worry about, you reduce the risk of bugs and that sort of thing. So that's billing itself and how you interact with it. So next we need to look at testing. When I say testing here, I don't mean unit tests or espresso testing, that sort of thing. I'm not talking about automated testing. What I'm talking about is I've developed this feature, and it might look one way for subscribed users and another way for free users. And I want to be able to give it to someone in my company, my designer, my QA person, anything like that. And they should be able to see both of those and to sort of manage that flow. All right, so this is really user testing. Google provides two solutions for this. They have static SKUs and test accounts. And we'll start out by talking about static SKUs. So what a static SKU is there are certain reserved SKUs that the Play Store knows about, and anytime you submit those in a purchase request, you're going to get a static response back. So those SKUs are android.test.purchased, android.test.canceled, and android.test.item unavailable. And as you would expect from the name, the purchase SKU is going to always return success, as if the user's been successfully charged and we come back with success, they've now successfully purchased this. Canceled does the same thing, but as if the user backed out, decided they didn't want to do it, their card was declined, anything like that. And item unavailable, I've never found particularly useful, but that's for a case where maybe you have a dynamic store and anything that a user tries to purchase that's not actually available for sale. So that's like an invalid SKU. So let's take a look at what that looks like. So with a static SKU, your user is going to say, I want to purchase com.sku.foo, which is really hard to say. So that goes into your app. The user taps a button, they interact with your app however they do. And what your app needs to do in your app code is do this switcheroo, where it's going to take, the user said they wanted to purchase com.sku.foo, but we're actually going to send android.test.purchased in this case to test a successful response. So that goes to the billing library, which sends it up to Google Play. Google Play is going to send back a success because that's the static response through the billing library back to your app, and now you get to shower your user with all of these features that they've just paid for. All right? So as you can see, this is a testing solution, but there are some problems with it. First of all, there's no inventory. And by inventory in this case, I mean you can't query with a static SKU and say, what has this user purchased? All right? And this is important for a couple reasons. First of all, in Play Store's in-app billing, you can have consumable purchases. So in a game, this might be something like coins or extra lives or gas, anything like that that the user can purchase, and then at some later date, they can consume that. You can't do that with static SKUs. To be fair to Google, consumable purchases didn't exist when the static SKU implementation was put into place. The other thing that this means, sort of in line with no inventory, is you can't do subscriptions. I mentioned my app is all subscription-based, so that makes this useless for me. The reason that is because subscriptions are based on that inventory. The way that you check if a user has an active subscription is you query to say, what does my user own? All right? And if they have an active subscription, you'll get a SKU back that's one of your subscriptions. And if by active subscription, I mean, they're either still paying for that subscription, so it's going to keep renewing, or they've canceled that subscription, but their current billing cycle hasn't ended. So those will still exist in the inventory until that billing cycle ends, and then when you query the inventory, that subscription is no longer there. So another thing, you can't do consumption. We talked about that. Since this is just a static response, we don't have an inventory to say, the user bought 3 gallons of gas, and now they're going to consume one of them, so remove it from the inventory. Well, you can't do that. There is no consumption because according to the Play Store, the only thing that this user has ever purchased is this static android.test.purchase SKU. And lastly, this is the one that really gets me, is you're not testing your actual code, all right? Because you have that switcheroo in there, what this means is that you're testing this sort of debug workflow, and then when you ship to production, you have a different workflow that skips that switcheroo, that maybe stores, part of that switcheroo is the SKU that you send to the Play Store is different than the one that you actually want to know they purchased when it comes back. So you have to store that SKU in some way. But that's not what you're testing when you're testing this. So what static SKUs, in my opinion, are really good for testing is just that purchase workflow. So basically the flow of they click purchase on the activity and it's going to go to that dialog that pops up and say, do you want to purchase this? Choose your payment method and then come back. That's the only thing. So that's static SKUs. Now let's move on to test accounts. Test accounts are sort of a different beast. What test accounts are designed to do is test the actual purchase flow in your app. So this allows you to use real accounts making real purchases, and the only difference here is that the user making this purchase will not be charged. So, the steps to implement test accounts. First, you need to add test user accounts to the Google Play console. So somewhere in your developer account on the Google Play console, you enter some Gmail accounts. And these are the accounts that are your test accounts. It should be noted that this is on your developer account on the Play console, not per app. So anybody who's a tester in one of your apps is a tester in all of your apps. Next, you need to deploy your app to the Play Store. Since your request is actually going through a cycle to the Play Store, you have to have this app deployed. It doesn't have to be publicly published or available. It can be published only in a closed test channel, but it does have to be uploaded to the Play Store. You then create products in the Play console, which you do just for any other in-app purchase. You install a release build on your device, and the release build here is important because this has to be signed with release keys. Part of the verification that the Play Store service on your device does to make sure that this is a legitimate purchase and there isn't fraud going on or something like that is it checks the app's release keys to verify that this is in fact who it says it is. Well, that's super annoying. Makes it really hard to test and debug. We'll get to that in a minute. And lastly, you then make a purchase with that test account on the device. When I say make a purchase with the test account, what that means, you notice every step of the way has a whole lot of caveats here. So what making a purchase with a test account means is that either the account that installed the app from the Play Store on that device is the one that's going to be used to make the purchase. If, on the other hand, you sideloaded this app or you installed it, from your USB cable, like a lot of us developers do, then the primary account on the Play Store on that device is the one that's going to be used to make the purchase. So, can't imagine there's any problems with that flow, right? It turns out that the problems are you have to know all of your test accounts in advance, which if you're talking about, a defined QA team that has certain devices that has, Pixite test account 1, Pixite test account 2, all of this on these devices, sure. But if I want to just, give a build to my designer so that he can quickly confirm that, I implemented this feature how he wanted, that gets a bit more complicated. I don't know which device he's going to use. I don't know what accounts he has and that sort of thing. Purchasable items must be published. This is probably more of an annoyance than anything, particularly with subscriptions, because subscriptions have a whole lot of restrictions about once a subscription is published on the Play Store, it has restrictions about if you can change the price, because people might have subscribed to it or not, and they're sort of locked into this price. Also, the terms, is it a 1-week subscription or a monthly subscription? Does it have a trial? All of that thing. And the reason I say this is mostly an annoyance is because you can publish all of these items that never appear in your app in production. But that means anytime you go into the Play Store, 6 months down the road, now you've got all this cruft from your development cycle that's appearing in there that you've got to sort of sift through, and it's just annoying, really. This has to be run on a device. According to the documentation, in-app purchases with test accounts only work on devices. Now, the caveat here is that since, I don't know when the documentation was updated, but we now have emulators that have the Play Store installed on them, and I have never bothered to test if this works in those emulated scenarios, but according to the documentation, test account purchases have to be run on a real device. I mentioned before that the app that you're testing has to be signed with the release keys. And this is problematic because it gets really hard to debug this flow. It's possible, and I've spent plenty of time doing it, manually enabling the debug flag in the manifest of my release build. Make sure you remember to, you can't release an app with a debug flag enabled, so the Play Store sort of makes sure that you don't forget to turn that off. But the other thing that this is challenging about this is that in my builds, I do a whole lot of stuff on the release build that I don't do on the debug builds. The big one being ProGuard. I ProGuard my release builds, and that makes debugging really difficult because now you've got obfuscation turned on and you can't see your method names, and tracing is really hard. And anyway, it's just don't debug release builds. Next up, you can't manually manage subscriptions. This is particularly important to me because I use subscriptions. And so the Play Store has all of these rules. They have this little chart that basically says if you use a test account, depending on which subscription you purchase, there's different durations and that sort of stuff. So just to give you an idea of how complex it can be, all test subscriptions will renew 6 times. I don't know why 6, but 6 times until they automatically cancel themselves. And the duration for a weekly subscription is, I think, 3 minutes, 5 minutes for a monthly subscription, up to 30 minutes for a yearly subscription. And so lastly, what this means is that subscription testing is slow. You can't manually say, I'm a subscriber and now I'm not a subscriber. What you have to do is you have to wait for that. You actually have to go into the Play Store. You have to switch your payment method to be a canceling or a declining payment method. And then you have to wait the 3 to 30 minutes with some variability in there for the Play Store to actually fail that purchase. If you have grace periods set up, then that adds a whole nother waiting period. And then you can go see what the app looks like for an unsubscribed user. So that's one example of how this makes it slow. Google actually has, they have a section in the documentation that they decided was too complex for normal people to look at, so they actually collapse it by default. If you click the little expander and you expand this thing out, they have some samples for, this is what a testing flow might look like. And to give you an example, if you want to test a yearly subscription and go through one test cycle where you're testing a few different things, that takes 3.5 hours because of these renewals, right? And that's kind of absurd. What that really means is that you can only test your yearly subscription twice a day if you work an 8-hour day and if you eat lunch. So those are the 2 testing solutions that Google has offered us, static SKUs and test accounts. And the way that I see it, these sort of fit into 2 buckets. Static SKUs, as I mentioned before, they're really useful in early development. When you're testing when I hit that button and it pops up the dialog, which means the activity the user was on is gonna pause and then it's gonna resume and it might be stopped depending on the memory state of the device, that sort of thing. Static SKUs are great for that, all right? Test accounts, those are really great for when you have something that's ready to go to release and you just wanna do that final testing to make sure that everything is going through the entire flow to the Play Store as it's supposed to. And it's okay that testing is slow because that doesn't happen very frequently. That's what testing accounts are great for. But that leaves this big open area in the middle. And this big open area for me might look like I'm working on a feature and it's gonna look a little different, to a subscriber and a non-subscriber. I wanna be able to give a debug build to my designer and make sure that things look right, that sort of thing. It's, that fast iteration cycle that we go for as developers. So, what does that question mark look like? Well, there are a few libraries out there, let me rephrase. There's one library out there that fills this void, all right, that I looked at. But it didn't quite fit some of the goals that I had in mind for something like this. So the high-level goal was to easily test in-app purchases and subscriptions, right? Everybody should have a mission statement. That's mine. So when I do that, I want to have easy integration with minimal code changes. I don't want to have to worry about bugs in the Play Store and this library and my own code, right? I would love my release builds to talk directly to the Play Store and not introduce anything else. I want no debug code in production. This is where that switcheroo comes around, where you say, if this is debug build, switch static SKUs and whatnot. In the same way, I wouldn't put espresso test code into my production app. I don't want code for these debug purchases in my release app, right? That's just real ugly. Next up, I want to allow easy inventory and transaction management. Like I said, my designer should be able to just flip a switch to say, I'm a subscriber, I'm not a subscriber, and not have to worry about, oh, what type of subscription did I purchase? Now I've got to wait 8 minutes or 30 minutes or whatever it might be, and how many renewals do I have left? It should be super easy. Lastly, I want a seamless user experience. These debug purchases, they should look, the flow for this should look and work as close as possible to the production app. I don't want my designer to have to say, well, this doesn't quite look right, and then I explain, well, that's because it's a debug build, it's gonna look different in production, just trust me. This should really be seamless and look similar. So what I came up with was something that I am, as of lunch, temporarily calling BillingX. And the idea here was this was sort of an extension to the billing, to Google's billing library. And let's see what this looks like. So did I miss my button? Yeah. So in the Play Billing library example that we saw before, we have the Play Billing library, which actually takes care of talking to Google Play for you. Your app only talks to the Play Billing library itself. With BillingX, you only do that for your release builds. In your debug builds, you actually talk to the BillingX library. And I'll show you how simple it is to make that switch without any actual code facilitating that switch entering your production code base. Now, the reason that we're able to do this and make it really easy and seamless is because of that billing client class that I mentioned before. This is an abstract class within the Play Billing library. And since this is abstract, when you request a billing client from the Play Billing library, what you actually get back is a billing client impl class. All right? You don't need to worry about that as a developer because you're just interacting through the billing client interface. But as a developer of a library who's trying to replace this, it's very important. And this is a valuable step. What we do for BillingX is actually re-implement that billing client abstract class with our own debug billing client. This debug billing client is then going to, instead of talking to the Play Store, talk to something else, which we'll get into in a little bit. And the reason this is so easy is because all of your app code that already talks to billing client doesn't need to change. The only thing that needs to change in your app to use BillingX in your debug builds is the code that actually fetches a billing client. All right? So let's take a look at what that looks like. So here's a pretty standard example. This is about as simple as it gets of how you interact with the billing client. And this is taken out of the Android Play Billing library sample. So the important piece we have here is where we instantiate our billing client. And we actually use a builder. This builder pattern should look really familiar. And what you say is you want a new billing client builder, you set a listener on it. Whenever purchases happen, this listener gets notified, you build it, and away you go. Now, to use BillingX, we simply replace that billing client builder with a billing client factory, all right? And you pass that same context, that same purchase updated listener to this factory. So just to highlight how simple that was, we'll go back, take another look. That's all the code in your production code base that needs to change in order to use BillingX. All right? And this billing client factory, I should note, this is not code from BillingX. This is the simplest example I could come up with of how to do the switch. If you use something like Dagger or Coin or any of the other dependency injection frameworks, use that to swap out an alternate implementation in your debug builds. This is just an example. If you don't use any of those dependency injection frameworks, I'm going to show you in just a minute how to create this factory that's going to do this and really simply. So that's our sample code, right? It doesn't look a whole lot different than it did before. All of the other code that interacts with billing client does not need to change. So what does that billing client factory look like? Well, in the release source set, notice this is source release Java, we implement this billing client factory. If you're not familiar with Kotlin, the object here is basically just saying that this is a static utility class instead of a regular class. So this billing client factory has a create billing client. which we saw before, takes an activity and a purchase updated listener. And all we're doing is we're moving that code from our activity into the factory. All right? And here's the important part in our debug source set. So source debug Java, we implement that same signature for that billing client factory, create billing client method, takes an activity and an updated listener. And in this one, we're going to return our debug billing client. The debug billing client, that's the piece that actually comes out of BillingX. All right? And so that's really all of the code changes. And then we go into our dependencies. And this is a little tricky. We're used to always adding new dependencies to this implementation. Can't remember what they're called, context. And what you're going to do is move the existing billing client dependency into your release implementation and add BillingX to your debug implementation. This is really important. If you want to keep your debug code out of your release build, you add it to your debug implementation dependency context. And this works just like the test implementation or Android test. The reason that you add your espresso code there is because then it does not get compiled into your release app. So as long as you do that, you can successfully complete our second goal. So as you can see, easy integration. The only thing that we changed in our production code base was replacing the billing client builder with the factory. And then we have no debug code in our production because we're only adding it to our debug builds. So next up, let's take a look at how you manage inventory and transactions. So I showed this diagram here before, which shows BillingX as this other thing. In my first iteration of this library, everything was contained in there because it's fairly simple behind the scenes, right? You have some fake SKUs that are available for purchase, and the user can purchase them, and we just need to track that. But I quickly realized that by breaking that part out into a billing store, BillingX became way more powerful. And so what that billing store is that's just a pretty simple interface that includes some methods that BillingX is going to interact with. So SKU details, these are the inventory of available items. So a SKU is an item that's for sale. So you can request from the billing store, get me all of the subscription items that are for sale, or get me all of the purchasable in-app items that are for sale. It'll return a list of SKU details. Well, our billing store does that, and by default, the one that comes with BillingX stores all of that stuff in shared preferences, because why not? And we also have the purchases. This is the purchase history. What has the user purchased? What do they own? What's unconsumed? Same type of thing. And then we have some methods that to manage the products that are available, the SKU details, and some methods to manage purchases. And these are for, in my case, I use a debug drawer. So you swipe out from the side in debug builds, and you have some, and you can manually adjust, if the user has made a subscription purchase, if they currently own a subscription, and that sort of thing. So in order to use this, when I mentioned that this is the only code that changes in order to use BillingX, you can do that, but you can't actually purchase anything because there's no items for sale. So we need to initialize our data. So this is going to be in our debug billing client factory. We initialize the data. This is just a helper method I wrote. We want to run this once because if we run it every time a new activity loads, we're just going to keep adding new items for sale. I actually don't do this in implementation yet. What I just do is erase all the products and write them again. But we're going to get that billing store. The default billing store, as I mentioned, stores things in shared preferences. That's probably going to change soon. And then we load an inventory. You can load that however you want. BillingX doesn't care. That can come from a JSON file in your debug assets folder. That can come from, in my case, it's actually just right there in the debug code in Java. It can come from a web service. It can come from some back-end service that lists all of your items for sale. And then for each of those items in the inventory, you just add it to the store. And that's it. So this really is, I promise, the last of the code you need to do to have a fully usable implementation of BillingX. Now, that billing store, aside from just being abstracted, what that means is that you can have multiples of them. So I mentioned that BillingX comes with one built-in. That built-in billing store is a shared prefs billing store. So that's going to store everything in shared preferences because it doesn't really matter. In my case, I don't have a very large inventory. You can purchase a monthly subscription with trial, a monthly subscription straight up, or a yearly subscription. So shared preferences isn't really a problem. If you have a big inventory, you're selling, I don't know, you have a game that's selling all sorts of in-world items, shared preferences might not be for you. And if that changes a lot, maybe you want to have a billing store that's backed by retrofit. It's going to reach out to your web service that returns your inventory of items. You could also do something like an Amazon billing store, right? Because why not? You could use BillingX to integrate with the Amazon App Store or any other app store by just swapping out the billing store, not actually changing any of your in-app code. So that's the billing stores and how we work with that. And what that allows us to do, as our third goal here states, is easily manage our inventory and transactions. Lastly, and this is actually a really short one, is I wanted a seamless user experience. So the way this works in BillingX, this is the current sample app, which is, I recommend you all download and make many, many purchases. If you touch that fab down there, you get this activity. So you'll notice this looks just like the Google Play in-app purchase activity. It's a dialogue, but it's actually backed by an activity, and that's important because I wanted BillingX to send your app through the same workflow. So that means that the activity with the fab, when you tap that fab and this pops up, that background activity is going to be paused. And then it's going to be resumed. And that's important because there are a lot of places that if you're not storing state correctly and that sort of thing, you can run into issues there. So, I put some red text in there to let you know this is really a fake purchase. But otherwise, you hit buy. And this activity, you don't have to worry about at all. This loads everything. All the details in this activity come from the SKU, just like the Play Store activity. So you click buy, and you're now a subscriber. And then I mentioned before that I use a debug drawer in my app. Since I just handle subscriptions, so that's sort of a on or off type of thing, I just have a switch in there. If you toggle that switch off, then I say, hey, billing store, remove all purchases. And if you toggle it on, I say, add a new purchase for a subscriber. All right? If you have more of an inventory, and actually something that I've got on the sort of on the roadmap for BillingX is to have this baked-in activity that'll let you manage transactions so you can have a bit more control over that. But this, in its simplest case, is really all that I need. So that is how I get a seamless user experience. So all of that being said, that is BillingX, and that's how BillingX for me is able to accomplish all of the goals that I was looking for. You can check it out on GitHub. Pixite Apps is my company. It's called BillingX. I'd love your feedback. Right now it's at a 0.8 release. It's not quite complete. What I'm working through right now is actually migrating Google's Trivial Drive, which is their in-app billing sample app. I'm actually migrating that to BillingX. And what that allows me to do is make sure that all these things like consumable purchases that I don't use in my app are implemented properly. When that's complete, we'll probably go to 1.0. But I've been using this for quite a long time in my app, Pigment. And it works great. And the nice thing about being only in your debug builds is that 0.8, 1.0, it's not that big of a deal because this isn't going out to users. But I found this super useful. My designer on my team, who's also my QA person on my team, has found this really useful, and I hope you will too, and I'd love to hear any feedback you might have on GitHub. Thank you.